Data modeling for NoSQL stores. Traditional database development will start by creating some logical and then physical data models. Most NoSQL systems do not have joins, and that will result in a different approach to models. The most common approach is to embed the data. Basically, we are dealing with highly denormalized models with the idea that everything is oriented towards high retrieval speed of our data. And that would mean that a piece of data may be stored in several different places in our system, but when we are retrieving the data, we can just grab everything that is needed to answer the particular query. So we are dealing here with the trade-off that data replication is often accepted as a normal thing, and the benefit is that we are getting higher read speeds. If you think, why is that the case? We see that response time of applications is critical for the success and a good experience of our users. And even reads that are slowing down our response time in a matter of hundreds of milliseconds are often viewed unacceptable by modern standards. One of the anti-patterns that we often see when we examine the databases that are too slow is when we have a conventional relational database developer who carries the knowledge from relational databases into NoSQL and start organizing the tables as they would do in a relational way. Normalized data models using references are typically going to result in very poor performance of the systems. That is the most important anti-pattern. Normalized data models are very flexible, and in a relational database, they can be used by running queries that we didn't know about during the design of the system. The problem is that joins will result in poor performance. Think about that most of the NoSQL systems do not have real joins. And that means that we often see joins being done as application joins in our programs, and they would have just terrible performance. Now, graph databases are a little bit different. Graph databases can follow links in a graph without necessarily performing joins. So you may have the normalized data model in the graph database, and you can still achieve good performance. Different systems use different implementation strategies, and I would highly recommend that you run benchmarks as you are developing to make sure that your normalized model in a graph setting would have adequate performance. If you are dealing with non-graph-oriented database, denormalization is the common approach, and normalized data models are usually going to cause performance problems. We can see that NoSQL is really not a perfect solution. We are going to trade off certain characteristics. For example, the flexibility and usability of the normalized data model, which would allow us to run different queries, even queries that we did not create during the development of the system. In the NoSQL world, this is typically different. We are going to design our data model so that we can answer the queries without performing joins. You should always remember that NoSQL stores vary, even within the same category. In order to create data models that are going to provide optimal benefits, you need to be aware of the internal organization of the data within your particular data store.